Hi team, once again I welcome you all to the AI ML with Kapil Panwar, and as per our promise, now we are starting with the statistics. So we'll start with the basic statistics and we'll try and understand that what are the various words which we are even learning from the 6th standard onwards, but what are the physical implication of those things and what are the real sense of those things. So today we'll start with the very basic of the stats, which is like the 3M, and those 3M's are like, so we all know them. These are mean, median and mode, correct? So what these things are, meaning of these things are like mean is nothing else but as a simple average, so we'll not put a lot of time. We know that everybody knows about this thing. Then median is like the middle one, like based on like whatever the data set which you have, the number which is coming at the middle if they are put on in a sequence. Then mode is the one particular item which is occurring the most of the time, correct? So what are the points of this, what are the drawbacks of these things, and which should you, what things should be used, like if I'm going with the mean, is it sufficient or not for my products? Okay, so let's just have some samples. So let me say that we have two data set, one is A and one is B, correct? So one has the data, suppose 1 2 3 4 5 and 10. B has the data of 1 2 3 4 5 and 6, correct? Now what will be the mean? So mean is nothing else, mean is the like summation of your x divided by number of samples, and this mean is represented by mu symbol, correct? So this is just about the formula, but now let's see that what will be the answer. So this is 3, so this becomes 15, correct? 15 and 10 25 divided by 6. So A is having 25 by 6, whereas for B this becomes 15 and 6, like so. For B the mean is 21 by 6, correct? So just we had this one number extra, you can see how much the number is coming, correct? For the simplicity, we'll just jump to our Python code and we'll see that what are the points which is coming. So we'll go to our VS code, correct? And yep, so now we are back to our VS code, and now let's see that what are the types of things coming. So I'm just going downside of the available notebook of mine, and now let's start making it here. Okay, so we make A. So our A was 1 2 3 4 5 and 10 number, correct? At the same time our B was is it visible, or like let me increase the size of this, correct? I hope now it will be visible. Done. So now let's go for the B. B was 1 2 3 4 4 5 and 6, correct? Now let's run this, find out what are the average. So I'm just using like in Python we can directly use np.mean function, which can be used for calculating the mean. So mean of A, comma, at the same time I'm pasting the mean of B, correct? Sorry, that's a typo mistake. So mean of A was 4.16, whereas mean of B is 3.5, correct? So this may be like one of the thing which it's like a outlier, correct? Now if I just make a data frame out of it, and let's see what happens. I just make a data frame, df equals to pd dot data frame, and now df of A is equals to A, and df of and df of B is equals to my B, correct? So we have just created a data frame. I'll just print this data frame for our ease. So yeah, this is what is our data frame. Now let's see that how their box plots looks like. df dot plot just kind equal to box. We all know that box plots we use for finding out the outliers and all, correct? So now if you see, the A has this train, but we have one outlier here, correct? Whereas this is the B. So outlier, we already know that outlier is a type of thing which we already need to filter out while making the statistical decisions. Like it's again based on the problem, like we really require this outlier or not. So now you can think that if we involve this outlier, our mean has reached 4.1, correct? Otherwise it should have 3.5. You can just come here and you can check that if I remove this, I consider this as an outlier, then my mean, this green line actually shows the mean, then this mean will be in the range of this. So let's try doing that thing, correct? So we'll just select the A's first 4 rows. So now let's first type in and see that is it really pasting like that. So I'm just selecting A column and then I'm gonna check its first 5 rows, correct? So this is still 5. Now if I take the NP or like the mean of this part, look, now its mean also falls within the range of 3, correct? So mean has one problem, that if you have the outlier in your data set and if you haven't done your proper maths to remove the outlier, and if you are directly going with the mean, definitely your outlier will spoil your mean. Okay, so this is the important part. You need to check your data before taking the mean. If you have these things, your mean will be poor. Now let's go for the median. What will happen? So np dot median of dfa. At the same time, I'll plot np dot median of dfb, correct? In such a case, if you see the medians are both equal, so this can be happen like we got a data where in A's last row was a mistake. Okay, the 10 was put it by mistake for there. So still if you see, then the median, if you go with the median is telling you that no, there is some else story. You had a higher mean but the same median, correct? It means you definitely have some of the outlier in your data if you normalize the, or if you see like the both the columns has some type of correlation within that, correct? Now let's see like what is the meaning of mode, correct? So if you see in this data, the mode means the number which is occurring more of the time, or the number which whose frequency is highest will be considered as the mode. If we see here, like we have each and every word unit is a unique, so this will be having the 0 mode, or either you can say like this has the 6 values of mode, but saying 6 different numbers as a mode is a have of no use. So nothing is like there, that's the best thing. So now how we will decide, like we should go with the mean or we should go with the mode, correct? So one thing, that only taking mean or only taking mode or only taking median is not a sufficient thing. We should try and calculate all these three. Like mode is depends on the availability of the data. If we have the available data, we should go with the mode. Otherwise we should just go with the mean and median, because this itself tells you the lot of story, correct? So it directly give you an idea, like you definitely your data has something which is treating as an outlier there, which you need to remove. Now let's go and think that what is the real significance of this mean, median, mode, and what about the normalized data, correct? So if I just jump into back to our platform, yeah, definitely we'll see that. No, 1 minute. Yep. So what we are going to do now is we'll see that what is the meaning of this mean, mode, median, and the normal curve. So I'm just plotting a chart here. Let's use this color this time to get the delta between that. So if you have some chart and if you plot that, and if it is in the shape of a bell curve means your mean, median, and mode all are near to the each other or almost equal, correct? If you have all these three values which are almost equal, that's called as the uniform distribute or normal distribution curve, correct? Now this may happen like while comparing the two of the data set, like they have really normal or not. This is the curve, but we may end up with this type of curve. We may also end up with this type of curve, correct? So now here, how to identify which is of what type. So the middle one is always the normal one, okay, which has mean, mode, median, all things are equal. Now definitely we have found out like these things aren't related with the median or the mode, correct? So something is differing from there. So the data, like the tail which is long on that side, it will be called that skewed. So we know that if I just draw a line from here, this is my left and this is my right, okay. So the tail, this its tail is long here, so this will be left skewed, and this has a long tail in the right side, so this will be a right skewed graph. Now we'll decide like what is the meaning or what is the significance about the skewed. Like if I just calculate the skewness, what will be the meaning or the implication of these things, correct? At the same time, there is a part which we call as a kurtosis. What kurtosis says that so this skewness is about this horizontal part, like how we are deviating from the normal, whereas kurtosis is about like on the vertical shift, how much from the deviation, correct? We may still be on the same mean, mode and median, but suppose previously we had this curve and now we have a really very sharp curve, correct? But we have the mean, mode, median equal. So that type of shift may be happen. So and slowly, like you may also have something which is gone as in left skewed and may have done like this kurtosis type of thing, where your peak has been either suppressed or has been even pulled out. So this is what is the meaning of kurtosis. So now let's just go and check on the PC side, like how these things really impact on each other. So we'll just go to the part and let's create a new data frame which we call as a NDF. NDF is a PD dot data frame. Okay, now I'll just make the NDF as a normal data, and the normal data can be generated like np dot random dot normal. Okay, here what we need to give, that what will be the mean of your data. So let's take the mean of my data is around 50, and what will be the standard deviation of my data. My standard deviation of my data is like 0.2, and I require the thousands of the values, correct? At the same time, I am just making one well list, and we are iterating it till 1000 time. Well, I in range of 0 comma 1000 time, and what we are doing is we are appending this well. So I am appending this well with np dot random dot rand. So what rand does is rand passes a value which is between like -1 to 1, and we are appending this value, and at the end, like I'll just add it with some I can say it as a other data which is not non-normal, okay, and storing this value within this. So we'll just hit it. So now we have the NDF ready with us. So if we go and check the NDF head, okay, so this NDF head has these things. We have the normal data, we have the other data too with us, and now let's just try and plot this data frame. So I'm just going the df dot plot, and we are doing the kind is equals to KDE, which is the kernel density plot. It's actually the density. It will just plot the bell curve of these things, like what are the probability on what part. Yep, superb. Okay, so if we see A is of oh sorry, we plotted the DF. Let's go with the NDF and then plot the same plot. Oh, super. It's more disturbing. I think we should stick with the data which we plotted previously, because this random data has really shown one part which is the so much shifted. So if you see here, this has a tail on that side, correct? But the data is between 0 to 1, and here we took the 50, so that may be a problem. So now let me just change it back to what, to take it as a 1. Let's take it as a 1 and rerun our part. Yep, and then run this and run this chart. Super. Okay, so this blue line shows about the normal data. Even we know that here it's a bit spread because the variation was a bit high. So if we want, we can just put it like 002, and now let's see and plotting this chart. So we are trying generating some normal, oh shit, it's a highly skewed now. So you will actually get the glimpse like what is the impact of the variation within the data. Correct. Now even if you see that this is more towards the normal, and its mean and mode in median will be around nearly 1. Okay, so just let's go and plot the ndf dot describe. So this ndf dot describe will generate the data set, and it has like the mean of 1, and this has the mean of 0.5. Let's just go and check. Yeah, it has the mean of 0.5, correct. So its mean has shifted from here. And also if you like if you check, we'll just go with the profile report. So I'll just go with the profile report, and profile report of the ndf, and that too has 2 widget. Correct. Let's plot this thing. So this profile report is it's a new tool which is from the pandas profiling library, and this actually helps in generating all type of statistics data available within each and every type of variable which you have. So we'll just see that what type of data it's generating, because nowadays the calculating each and every parameter, it's only a time consuming. So this is a function which you can calculate for you, and it will generate a type of a summary report here. So till the time we can just see that its kurtosis has suppressed. Okay, so the peak, if we see, is that this was my normal bell curve, then the peak has been reduced from top to down, and just because of this pressure it has now the widespread. Correct. Now with this widespread also, like it has shifted for this side. So this is like a type of a right skewed, because it's shifted to the left orientation, and the right side it has a long tail. So it's a type of a right side skewed data, and also from the kurtosis part it has been suppressed. Correct. So now let's go and see. We'll go for the variable part. In variable you can see that it has a pretty fine and better things here. So if you click on this toggle details, it will give you all the statistics parameter calculated. So right now we are under the head of this normal part. Correct. So for the normal, if you see, the kurtosis was in minus 0.14, so like it was in some other direction. At the same time, if you see the skewness was also like the minus 0.7, 0.07. Correct. We try and keeping like the skewness should be 0 and the kurtosis should be 0 for plotting the normal data, but that's an ideal case, and we failed to doing that, because if you see, we still have a sharp cut here. Correct. At the same time, now if we go and we check for the other type of data set, like our second data, and we check the part here, you will see that its kurtosis from that minus 0.17, it has increased to 1.1. Okay, so even though that was a bit suppressed, it's a highly suppressed kurtosis. Correct. If it was a positive, it should have gone to the more narrowed down on the top side. Also for the skewness, this shows that now this is in the minus 0.046. So minus 0.046 can be represented as minus 0.05, whereas previously we had the skewness of minus 0.07. Correct. So now it means like it has a bit shift from here to there. Correct. So this curve is not like more on like how it has shifted. So its skewness has shifted a bit. Okay, but kurtosis is like that the part is too high. Now we'll see that what is the impact of the variation. Correct. So what is the variation in actual? So for understanding the variation, we'll again like jump to our board, and we'll try on. Let's try and see that how we can create one new board here. Let me create one more new frame. Okay, this part is okay for me now. And now let's see what is the meaning of variation. Correct. Now let's see first let's understand what is the formula of variation. So variation is like the formula of variation is like how far from mu, that is mean. Okay, so suppose I have this line, this is what is my mu, this is my x1, this is my x2. Just for simplicity I am taking the two parts, so I am finding out this distance and this distance. So definitely one will be in positive and one will be in negative. So just for making the change, what we do is we just take the x of I minus mu and we take the square of that, then we just take the summation of that and then we divide it by the number of samples available. Correct? So this is how we calculated the variance. Now variance, like the higher the variance means the distance is high. Correct? Now variance is a very typical thing because we have taken here the square. So if the distance, like if the distance even increase with the delta d, correct, del d, like a bit of distance is increasing, the square of that is increasing in the resultant. So that's why like increasing a bit of variance will have a larger impact on the skewness. So if we just go back to our curve, we'll see that how much it has the real implication on that part. So just let's come back to our code and let's generate two different type of normal data. Okay, so we'll just come down here, yeah, and we'll try and publishing one more data, and this time it will be with NDF. I'll say N1 normal one, and I'll generate the same set of data. Correct? Just a second. I'll generate the same set of data with the N2. Okay, where what we are doing is we are increasing the variance. So increasing variance means it should have a wider spread. Let's check that is it really true or not. Correct? So we are increasing this with this NDF, and then at the end what we are gonna try is we'll plot the NDF, then we'll just take as N1 and comma N2, and then we'll just do the plot, and the plot will be of kind is equals to KDE. Let's see what is the output. Look, we had the same mean and median, just only with the simple change. Now let's try with the 0, 1 and 1. Okay, this is just a minor change. That was 20 and this is 21. After that, let's see even what is the implication of this thing. We have a more down curve, we have a more flat curve. Okay, you see that it has increased from this part. Correct? For the major, if I just change it from 20 to 30, if you run it, you will see the more down part and it will be more spread. Look like this. Correct? So this is how like it's the variance has a direct impact on the kurtosis part. The more the variance, the more the flat curve will be, the kurtosis will go in more minus or the negative part, and the chart will be having the widespread. Correct? Whereas for the skewness, it will just have a left and the right spread. For skewness, like the shifting of your mean itself has an point. Here we didn't change the mean. Correct? Now let's just try and keeping my variance as same and change my mean. Now let's see how the chart will be plotted. Look, we had the same thing, but now if you check the skewness of this thing also, it will I don't think so it will be having the major impact on that. So let's just again generate the report of this thing. So I'm taking the profile report. So we'll generate the profile report of NDF, keeping only two column, which is the N1 comma N2. Okay, and that's to widget, because I want to see it here only. So the moment we pass this code, it's starting summarizing data, making all those statistic calculations, and very soon it will generate the results for us. So the data has been calculated, the structure has been prepared, now it's rendering the widget. Once it's rendered, it will be displayed here. Okay. So what do you think, that the skewness will be changed? The variance hasn't changed, so the kurtosis shouldn't change much. Correct? So we'll just take a note this time. Yeah, so the report has been generated. Let's just go upside a bit and see the data. Wait, we have to go into the variables. Yeah, we are in N1. In N1, when I toggle the data, just check the skewness we had is a 0.08. Okay, and just go and check for the N2. For N1 0.08, for N2 0.12 in negative. Correct? So it's been shifted from positive to negative, means your entire stack has been shifted because your mean has changed. Done. At the same time, now just check the kurtosis has the 0.2, you can consider it as a 5.246. And what's the kurtosis here? Look, it's also in a negative. So are we seeing some change in the peak? Correct. So there isn't a change in peak, but still this thing is happening. Right. The moment you are changing your mean, or you are making the same replica of your data set, but your mean is shifted, you may end it with a different kurtosis or with a different skewness. Correct. But this doesn't mean like that it's not in that part. So what we'll do for that reason, if we just go and we'll now let's see what happens with both the part. Super. So this time we have a shift. What do you think that if I just plot a middle line between this thing, do you think that it has the more right side here and the low left side there? So ideally it should be shifted towards the left skewed, correct? Because it has a long tail on the left side. And on the kurtosis part, absolutely like no, we are just talking about this orange curve. So this one is our n1, which is the reference, and this is what is there. So between this to this has definitely a higher peak. So this value of kurtosis should be more than this value. Okay. At the same time, the skewness of this will be more in negative terms from this if we compare. So let's just go and check like if the data has been generated. Yeah, it has the generated data. Let's go to the variable. The n has, if I toggle the data, yep, so n has the kurtosis of 0.16, like that's 0.2, or even that's in negative. Just wait, it has negative 0.164. Now for the n2, that is in positive 0.15, correct? Why it is positive? Because this time your kurtosis peak has increased from the base. Also now coming to the skewness, if we come and check the skewness for our n1 first. So our n first skew was minus 0.05. Okay, now let's see where it will be for the n2. So for the n2, the skewness will be in the minus 0.05, it's minus 0.091. Okay, so it means like it has been shifted towards again the negative side, which is like the right side skewed. Correct. So this value in the change itself shows that the mean has been shifted, and also like the part like the kurtosis part has been shifted. But now what will be the impact of this thing on the scatter plot? Correct. We are talking from a long about this thing. So now just let's go and plot ndf dot plot, and that's 2 is the kind is equals to scatter, where my x should be n1 and my y should be n2. Let's just see the plot. Look, this it's a totally spreaded data, correct? I don't know what will be the correlation between them. So ndf and let's sorry, we will just select the required columns only. So let's go with the n1 and comma n2, and then try it with correlation and just hit it down. This is what is the correlation, and the reason for that is it's not that properly skewed or the things, correct? Now let's see and let's plot two more things and then see what will be its implication on the correlation. But yeah, remember that they both are the random data, but their density curves feels like that. So we'll just come down here. I'll just work, I'll paste this line, then the same line. I'll make this as a 3 number now, make this as a 4 number now. Then I'll just try and printing this correlations, but between 3 and 4 this time. Correct. And at the same time, what we'll do is Look, already we know that the correlation is very bad. We'll go for the NDF. Sorry, I'll just take it from here only, and we'll try and plot there. Kind is equals to KDE chart. So yep, both the data are like almost normal, but yeah, definitely one where it sees like it's the N3's variation is higher than this orange one, correct? So even we can go and we can check about the variance. So again, like we'll have to generate that PDF profile report. So now you can generate your profile report at your own, and you can play with the data. But the most and important thing is the data normalization doesn't mean like the data itself will be having some of the correlation between them. The data normalization means like their values lies within the things. The data is not having some types of outlier. This data is suitable to go for the statistical analysis further, correct? After this thing we just check for the correlation. So we show from here like even when your data has that level of disturbance, like this was our first data, n2 n1 and n2, okay, this data was that disturbed. We also saw the scatter plot of this, and then we plotted the uh, like correlation between these two data set, correct? So this doesn't have that level of thing. Also we generated the very similar type of normal distribution data. So this both data are like nearly normal, okay, we can proceed with this thing. But again, if we check the correlation really very bad. So this really implies that the normalization has nothing to do with the correlation part. The normalization is more about that how your data is spreaded, how your data's mean is, where it is it like really as the bell curve or not, is it skewed, is it kurtosis, or does it have some type of outlier? So your data will be skewed if it has the outlier, okay. Your data will be having the more difference if it is the variance. The variance can let you know that you should take the median or the mean. So all these types of information you can obtain from this skew and kurtosis and the mean mode median type of part along with the variance. I hope this was good. I know that this lecture has really gone along, but this was really necessary for understanding the basics, because this data and these parts will really be helpful for you before passing to the model. Yeah. And even though like we are connecting after 3 days, so this much material you should expect. So now I'm collecting all this 3 days data, and we have delivered it together in the 32 minutes or 34 minutes of the span. So I hope that you will like this video. You can just take a pause. You can go with your own pace and your speed, and also you should try this by changing the lot of variance, mean, and the number of samples, and you should try and plot, and you should be having that much confidence that after seeing a bell curve you are capable of telling that the type of skewness, does it have the outlier or not, how much like do you really need a further type of treatment for this data, or like is it good to go for the model. This was our end goal. Okay, we hope you love this video, and also like keep sharing with your team. Thank you so much.